Okay, so now that we have RVD done, we can move on to RCA, the final RCAT tool. So I'll open the build RCA project, and this is basically going to be the same as RVD. All the inputs are the same except we have a fragmented valley bottom instead of the regular valley bottom, and there's documentation on how to produce this elsewhere and in the Word document. But basically, it's a valley bottom that's been split up and fragmented to differentiate between what's accessible, what part of the floodplain is accessible and what part's not. So we will start building this project same way we did the other two. We're just going to create a new folder, and everything is the same. Except we're going to call it RCA at the end. Oops. There we go. Add that. So select existing cover. This is just the vegetation, so we can actually go back and grab this from our RVD project in the existing whole folder. Same with historic. BPS. Select drainage networks. We use a segmented one for this too, so we can actually grab this from the RVD project as well. It uses the same network. So the fragmented valley bottom, since this is the only new data set that we're introducing since the last project, just make sure that this data set's projected and fully encompassing of the watershed. So we'll go back to where I have that saved. This is Yankee Fork floodplain connectivity, and then once again, if we had a large river polygon we need to use, we'd input that here. We'll just hit OK. Alright, it succeeded. I'm going to refresh the toolbox, go into my folder. So now let's move those inputs over, and then the difference here between RVD is we have a fragmented valley. So just like we did in RVD, we have a new input that we've pulled from somewhere else on the computer, so we need to change its name following what the Word documentation says to name it. So in this case it's just the Huck ID. And then FP for floodplain, and then connectivity. And that's good to go. So we are good to move on to the actual RCA tool. So like I've done in the past with RVD and VBET, I'm just going to close out of ARC and get back into it so nothing weird happens. Alright, so I'm back in ARC. I'm going to open up the toolbox. And we're going to run the riparian condition assessment. So it's going to look very similar to the other ones. Project name again. RCA this time. Project folder, I'm going to select RCA this time. Select the existing cover within our RCA project folder. I'm going to do the one that's clipped again because this is the one that's to the watershed boundary. Same for historic. Grab our network. And then our fragmented valley or floodplain connectivity. We don't have a large river polygon, so the new thing you have to deal with here is the width threshold, and 190 is the default. So the nice thing about this project is you can run it on multiple different thresholds and it'll just keep creating new output folders that save what threshold they used, and you can find what it was run at in the XML. So I'm just going to leave this at 190, and the documentation on how to calibrate what threshold you use is in the Word documentation, so there's good description there, but we're just going to leave it at 190 for the tutorial, and then we'll name our output same as like we did for RVD, just the HUC ID and RCA at the end. And we'll run that. Alright, so the RCA tool has succeeded. I'm going to go over here and refresh the folder. And go into analysis, output 1. There's our RCA. So once again, it's just a line network. Double check this and make sure it did everything we needed. I'll import the proper symbology out of the toolbox here. And it looks like it worked. As you can see, basically everything on, or the large majority of everything on here is confined. So this is where I was saying it would be good to make another run of the RCA tool with a different threshold. So what I would do is open up the results, and I would simply just change this threshold to include more area, and then you'd get another output folder. It'd be output 2. You'd have the same RCA named in there, and you'd basically run it until you get to the threshold that lines up most with the confinement value outputs from the confinement tool. So that is all the ARCAT tools, and should do it.